Astronomers using ESO's world-leading HARPS instrument have discovered a planetary system containing at least 5 planets, orbiting the Sun-like star HD 10180. The researchers also believe the system has 2 other planets, one of which would have the lowest mass ever found, making the system similar to our own solar system in terms of the number of planets. Furthermore, the scientists find that the location of the planets follows a regular pattern, as also seen in our own solar system.
This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
The team of astronomers used the HARPS spectrograph attached to ESO's 3.6-meter telescope at La Silla, Chile. HARPS is an instrument with unrivaled stability and great precision, and the world's most successful exoplanet hunter. The astronomers, led by Christophe Lovis from the Geneva Observatory, studied the Sun-like star HD 10180 over a period of 6 years. This star is located 127 light-years away in the southern constellation Hydrus, the male water snake. Thanks to the 190 individual HARPS measurements, the astronomers detected the wobbles of the star caused by 5 or more planets. The 5 strongest signals correspond to planets with Neptune-like masses, between 13 and 25 Earth masses, which orbit the star in between 6 to 600 days. The astronomers have also strong reason to believe that 2 other planets are present. One would be a Saturn-like planet orbiting in 2,200 days. The other, having a mass of only about 1.4 times that of the Earth, would be the least massive exoplanet ever discovered. This suspected planet is very close to its host star, and so it's likely to be very hot. 1 year on this planet lasts only 1.18 Earth days. The newly discovered solar system is unique in several respects. First of all, with at least 5 Neptune-like planets lying within a distance equivalent to the orbit of Mars, this system is more populated than our own solar system in its inner region, and has many more massive planets there. Furthermore, the system probably has no Jupiter-like gas giant. In addition, all the planets seem to have almost circular orbits. Dynamical studies of the new system reveal complex interactions between the planets and give us insights into its long-term evolution. Using the new discovery as well as data for other planetary systems, the astronomers discovered that the locations of the planets seem to follow a regular pattern, similar to the Titius border law that exists in our own solar system. This could be a general signature of how planetary systems form. Another important result is that all very massive planetary systems are found around massive and metal-rich stars, while the 4 lowest mass systems are found around lower mass and metal-poor stars. These properties confirm current theoretical models. There is no doubt that this remarkable discovery highlights the fact that we are now entering a new era in exoplanet science, the study of complex planetary systems and not just of individual planets. And with HARPS, European astronomers will be a driving force behind this transition.
For the first time, astronomers have been able to directly follow the motion of an exoplanet as it moves to the other side of its host star. The planet has the smallest orbit of all directly imaged exoplanets so far, lying as close to its host star as Saturn is to the Sun. This discovery proves that gas giant planets can form in only a few million years, a short time in cosmic terms.
Hello and welcome to the ESOcast. In this episode, we'll talk about the planet around the star Beta Pictoris. This star has not quite twice the mass of the Sun, and it's about 12 million years old. Although this sounds like a lot, it's actually a really young star. For example, the Sun is already about 4.7 billion years old. Beta Pictoris is one of the best known examples of a star surrounded by a so-called dusty debris disk. Now, the debris in this disk comes from collisions among larger bodies, such as planetary embryos or asteroids. Earlier observations had already shown that this debris disk is actually warped and that there are comets falling onto the star. Now, these are telltale signs that strongly suggest the presence of a massive planet in orbit around the star. Now, with the new observations obtained with ESO's Very Large Telescope, we have definitive proof.
Because the star is so young, the planet must also have formed in only a few million years. This is good news because we already knew that disks around young stars disperse in a few million years, and astronomers were looking for proof that giant planet formation can occur within this time. The planet has a mass of about 8 Jupiter masses. It has the right mass and location to explain the observed warp in the inner part.
The team used the NACO instrument, which is mounted on one of the 4 8.2-meter unit telescopes of ESO's Very Large Telescope, or VLT. They observed the immediate neighborhood of Beta Pictoris in 2003, 2008, and 2009. Now, the 2003 observations clearly showed a massive planet in the disk, but in 2008 and in early 2009, it had disappeared. However, in the most recent observations in late 2009, the planet has reappeared, but on the other side of the star. Clearly, in the earlier observations, the planet was hidden either in front or behind the star. So now, for the first time, we can actually see an exoplanet moving around its host star from one side to the other. This also gives the astronomers a much better estimate of the distance between the star and the planet.
Among the handful of planets already imaged, the planet around Beta Pictoris, designated Beta Pictoris b, has the smallest orbit so far. It is located between 8 and 14 Earth-Sun distances, or astronomical units, from its star. This is about the distance Saturn is from the Sun. The short period of the planet will allow astronomers to record the full orbit within the next 15 to 20 years, and further studies of Beta Pictoris b will provide the first insights into the physics and chemistry of a young giant planet's atmosphere.
Super-Jupiters, like Beta Pictoris b, are exceedingly rare around Sun-like stars. However, the planets found around the star's Fomalhaut in HR 8799, together with the existence of Beta Pictoris b, seems to suggest that super-Jupiters may be a more frequent byproduct of the formation of stars that are more massive than the Sun. Such planets strongly disturb the disks around their stars, and that creates structures that will be easily observable with ALMA, which is a revolutionary new millimeter and submillimeter telescope that is being built right now by ESO together with international partners.
A few other exoplanets have been imaged, but they're all located farther away from their host star than Beta Pictoris b is. If located in the solar system, they would lie close to or beyond the orbit of the farthest planet, Neptune. The formation processes of these distant planets are likely to be quite different from those in our solar system and in Beta Pictoris.
The recent direct images of exoplanets illustrate the diversity of planetary systems. Among these, Beta Pictoris b is the most promising case of a planet that may have formed in a similar way as the giant planets in our own solar system. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.